today's topic comes from 2.2, polynomial function of higher degree. We're going to be able to use end behavior and transformations to kind of sketch a graph a little bit, find the zeros, and then given the zeros, write the equation. All right, so first of all, we're going to start off with reminding ourselves of the end behavior. So we have what's called the leading coefficient. And then we have the degree. And that determines end behavior. So if our leading coefficient is positive, so for example, on ax squared, a is positive, and the degree is even, the end behavior such. Okay? If the leading coefficient is negative, like in negative ax squared, and the degree is even, then the end behavior is such. It opens down. Now we have, if the leading coefficient is positive and the degree is odd, then our end behavior is like this. And if the leading coefficient is negative and the degree is odd, then our end behavior like this. Now let's talk a little bit about the zeros of a polynomial. The polynomial function f of degree n, the following statements are true. The function has at most n real zeros, and the graph has at most n minus 1 relative extrema or minima or maxima. This means how many turns it takes. And number 1 means that if it's like an x squared, it has at most 2 real zeros. X cubed means it has at most 3 real zeros. Could have less. Real zeros of polynomial functions. These all mean the same things, these 4 statements. Once we solve, if we say x equals a number, then it's a 0, and it's a solution. If it's also a number, that a is the x-intercept of the graph, written as a point. If it's a solution, then x minus a is a factor of the polynomial. If we solve, here's a vocabulary, if we solve and we have multiple or same zeros, a 0 repeated, it's called multiplicity. And we'll look at some examples. So first we're going to find all the real zeros and x-intercepts and then sketch the graph. Okay? So if we're looking at this one, the only method we have right now is factoring or quadratic formula completing the square, those methods. Okay, so let's first, greatest common factor is an x. Now let's factor this. So then I factored this trinomial into 2 binomials. Now when I solve those, these become my zeros. My zeros, x equals 0, x equals 2, and x equals negative 1. Those are my zeros. My x-intercepts are going to be at 0, 0, 2, 0, and negative 1, 0. And if I'm sketching this graph then, put our x-intercepts onto the graph. 0, 0, 2, 0, negative 1, 0. And it's odd. My end behavior has to go like that because it's odd and it's positive leading coefficient. Connect the dots. Sketch of the graph. Again, let's factor. Factor out an x. X squared minus 12x plus 36. And since I'm finding the zeros, I said it's equal to 0. Factor the trinomial. So x is going to equal 0, and x is going to equal 6, but since there's 2 of them, this is where it's called repeated, so it's going to we call that a multiplicity of 2. That means that 2 6s are the 2 zeros. So these are zeros. Now our x-intercepts, we're going to have at 0, 0, and at 6, 0. 0, 0. And let's call this 3, 4, 5, 6, 6, 0. It's odd with a positive leading coefficient. So how do I sketch this? Well, we know it doesn't cross the x-axis at all, so it's got to go something like that, maybe. And so it's going to turn right at 6, 0. Last one here. Okay, so we're going to factor out a negative 2x, again, to solve. Actually, a 2x squared. And we're going to have then x squared minus 1 equals 0. Well, I can continue to factor that. That's a difference of squares. Or I could use the square root method, which is what I prefer. So first, let's solve this for 0. Well, the only thing, if I divide by a negative 2, x squared equals 0. So x equals 0, but that's going to have a multiplicity of 2 because of the x squared. All right, now let's solve x squared minus 1 equals 0. So x squared equals 1. So x is going to take the square root of both sides. X is going to be plus or minus 1. So my intercepts, my x-intercepts will be at 0, 0, 1, 0, and negative 1, 0. Let's sketch the graph. 0, 0, 1, 0, negative 1, 0. Okay, so my leading coefficient is negative, and my degree is even, so it's going to have end behavior that goes like that. It cannot cross the x-axis anywhere anymore, so I have to be able to be careful how I connect my dots and say it turns right there. Something like that. Okay, so that's end behavior and sketching the graphs. Now we're just going to find the function that has a 0, so we work backwards. If 2 is a 0, then the factor has to be x minus 2, right? If x minus 2 equals 0, it would yield me 2, and the other one would be x plus 3, and this would be my function. Let's multiply that out. So that would be x squared plus 3x minus 2x minus 6. So my function would be x squared plus x minus 6. Now we have 3. Okay, so 5 is the solution. I'm going to have x minus 5. If negative 1 is the solution, I'm going to have x plus 1. And if negative 5 is the solution, I'm going to have x plus 5. All right. Recognizing that I have x minus 5 and x plus 5, that's a difference of squares. So I'm going to multiply those out first. In other words, I'm going to write it like this. If you didn't recognize that, you could multiply any two binomials together and then multiply it by the third. So I'm going to multiply these two together first. So that's x squared plus 5x minus 5x minus 25. And I still have an x plus 1. So this is going to be x squared minus 25 times x plus 1. So now I'm going to have to take and multiply this out. Okay, so I'm going to work backwards. By multiplying this way. So this is going to be then x cubed minus 25x. Okay, and then I take the 1, and that would be plus x squared minus 25. Write it in standard function order, descending order, x cubed plus x squared minus 25, x minus 25. Last two. Okay, D is a little complicated. Okay, if 1 is a solution, it's going to be x plus 1. If x is a solution, it's going to be just x. I mean, if 0 is a solution, it's an x. Now, when you have a fraction, remember that denominator has been the coefficient on the numerator every time we solve this. So if I solve 4x minus, or if I wanted to figure it out, I don't see that, I'm going to say, how do I want to say this? Okay, so I'm going to multiply both sides by 4. We get 3 equals 4x. Now subtract 3 from both sides, and I would get 0 equals 4x minus 3. Okay. Now, let's go ahead and multiply this through. So that's x squared plus x. And then so this is my function. So that's 4x cubed minus 3x squared plus 4x squared minus 3x. Combine our like terms, we get 4x cubed plus x squared minus 3x. All right, so this one is really tricky. We're going to take this, and we're going to work backwards like we did earlier, and like we did with the 3/4. This is a plus minus. So this is saying that x is equal to 2 plus or minus square root 11. First thing I'm going to do is I'm going to work backwards. I'm going to make this thing equal to 0 somehow. So first thing I'm going to do is subtract a 2. Now, to get rid of the square root, I'm going to square both sides. So I'm just kind of working over here now. So x minus 2 quantity squared equal 11. I want that equal to 0. Okay, because that's my 0, right? That's what I'm saying. That's what I'm saying there, that those are zeros. Now, multiply this out, and you get x squared minus 4x, because remember it's x minus 2 times x minus 2, plus 4 minus 11 equals 0. That's x squared minus 4x minus 7 equals 0. So this here, when I put it back into its function form, is x squared minus 4x minus 7. But I still have this 0, so I need to deal with x minus 3. Now multiply that through. I like writing it in a little different form. So here's x cubed minus 4x squared minus 7x. So I distribute the x. Now I'm going to distribute the 3, but I'm going to write it underneath there. Minus 3x squared plus 12x plus 21. Okay, now I'm going to combine my like terms. So my function, f of x is equal to x to the third minus 7x squared plus 5x plus 21. Those are probably the most difficult of all of them.